Check the mic and make sure it sound right, boys.
Hey everyone, and thanks for tuning in again. In this video, we'll begin by computing correlations. I'll show you how to compute a correlation between two variables, as well as a correlation matrix, which is for your entire data set. What we'll do next is we'll start estimating some regression analyses. The first one will be a simple linear regression, which is a regression analysis with one predictor. The second one will be a multiple linear regression analysis, and in our example, we'll be looking at two predictors. For each of these regression analyses, I'll be providing some example write-ups showing you how to interpret the results. So to begin, let's go ahead and open up SAS and we'll get started with the lab. Okay, so now that we have SAS open, the file that I've actually opened is called week4_template SAS. I've uploaded this online, and what this contains are some headings using comments to organize the syntax that we're going to type out today. So you can use this template if you want, or you could just start with a blank SAS syntax file. Either one will work. And what we're going to do to start is we're going to read in our data. There's a tab delimited file called regdata2 that I also uploaded online, and we'll be using that data set today. So to import, we'll go to File, Import Data, and I'm looking for a tab delimited file, so I'm going to click right here for tab delimited. Next, I'm going to browse my computer and find the file. So mine is in the C drive in the datasets folder. And as you can see, nothing is coming up, and that's because the file type is limited to .txt. So I'm going to change that to all files. And then regdata2 is right here, and this is the DAT file. This is the one that I want. I'm going to go ahead and open that. Click Next. You want to give the data set a name, so I'm going to call it regdata2. And then I can just click Finish here after giving it a name. And then here you can see regdata2, 150 observations, 6 variables. So it looks like everything read in correctly. I'm going to go ahead and go into my libraries just to check in the work folder. And then here's the data set, regdata2. I'll double click on that. Yep, and it looks good. So we have a y variable, and then we have x1 through x5, very similar to regdata1. And then we should have 150 observations. Perfect, which we do. Okay, so everything data-wise looks good. Okay, so the first thing I'm going to run is ODS HTML. We've done this before, and this is setting our output delivery system to HTML. Okay, and then these lines of code here we will save for later. So remember, this line and these last two lines here are for compiling our output into a Word document so that we can copy and paste tables and graphs. So I'm going to keep those, as you can see it's green right now because it's commented out, but I'll uncomment those out later, and then we'll use those lines to compile to a Word document. So I'm going to start with here is I'm going to run a correlation between x1 and y. So to do that, we're going to be using the core procedure. So prop core, it's with 2 R's. And then we're going to specify what our data set is. So it's regdata2, and then a semicolon. And then here, we use the var statement, x1 and y. And then we close with run. So we'll highlight that, and then remember the submit button is up here. It's the little running man. All right. So SAS gives us some simple statistics or descriptives. We have our mean, standard deviations, minimum and maximum. And then we have our correlation here. So the correlation between y and x1 is 0.24. And then below it is the p-value. So that's less than 0.05, so this correlation of 0.24 is statistically significant. And as you can see, it's in matrix form, but I'll describe more about this when we do the full correlation matrix. Okay, so that's the correlation between x1 and y. Moving on to the next example, we're going to use the core procedure again. Again, the data set is reg data 2, and this time if I don't specify any variables with the var statement, it will just give me the full correlation matrix with all of the variables in my data set. So that's y and then x1 through x5. So I'm going to highlight that and I'm going to press submit right here. Again, we get our descriptive statistics, and then what I want to focus on here is the correlation matrix. So this looks like a lot of stuff, but technically you only have to look at half of it. So as you can see, we have ones on the diagonal here. This is called the main diagonal. And the reason why they're ones is because if you correlate y with itself, it's 1. If you correlate x1 with itself, it's 1. x2 with itself, it's 1. So everything on this main diagonal is going to be a 1. Now, when looking at this matrix, you only have to look at either the what's called the top triangle and the bottom triangle, because all the values here are reflected. So if you're thinking about, let's say we want to look at the correlation between y and x3. So here's y. We go down to x3, and it's 0.29, 0.29704. And this value is reflected on the other side, where y is right here on as a row header, and then if we look for x3, it's the same value, 0.29704. So again, this top triangle is just a reflection of the bottom triangle, so you can focus on one of the halves and you don't have to focus on the whole thing. Okay, so in this matrix we have the correlation between all of the variables, and so we have all the correlations for y, all the correlations for x1, for x2, x3, and then x4. And then x5 is this bottom row right here. And that's if we're looking at the bottom triangle. And so the way that everything is set up is that the first line is the correlation, and then the second line is the p-value. So here we already saw this correlation, it's statistically significant, but if we're looking at, for example, x1 and x2, the correlation is 0.08661, and the p-value is 0.2920, which is greater than 0.05, so it is not statistically significant. Okay, so that's our correlation matrix. Next, what we'll be looking at is running a simple linear regression. So this is a regression with one predictor. And to do this, in SAS, we're going to use the reg procedure. So proc reg, again, we're going to specify what our data set is. And then the next thing we do is specify our model. So our model is y is predicted by x1. And then I'm going to include a slash and then STB, because I want these standardized coefficients in addition to the raw coefficients. And that's it. And then we'll end with our run statement. And I can highlight this, and then I'll run it. Now SAS will give us a bunch of extra stuff, like diagnostic plots. Yep, this. So we have this diagnostic plot. We have a plot here of the residuals and the predictor. More diagnostic plots, but we're not going to pay attention to that right now. All we want to see is the output for the regression model. And so here we have our ANOVA table. We have some other summary stuff like the R-squared, the adjusted R-squared, and then we have our parameter estimates in this last box here. So starting with the ANOVA, we have our model sum of squares, also known as the regression sum of squares, and our error sum of squares, or the residual sum of squares. We have our degrees of freedom, and then using the sum of squares and the degrees of freedom, you can compute the mean square, and then taking the ratio of the mean squares, you get the F value right here, and then the associated p-value. Remember, this is in terms of the model, but since we only have one predictor, which is x1, then the model is simply x1 predicting y. So this F value, or this F test, will actually reflect the t test for the individual coefficient because there's only one predictor in the model. All right, so looking at this, the p-value is less than 0.05. So the F statistic is significant, and so the model significantly predicts Y. Our R squared here, we have a 0.0582, so about 6% of the variance in Y is accounted for by the model. And then our adjusted R squared, to think of this simply, it's if the discrepancy between R squared and adjusted R squared is large, then there are predictors in your model that are not contributing. It's like they're not carrying their own weight. So there are predictors in the model not contributing a sufficient amount of prediction for the criterion Y. So to put it short, you want these numbers to be close to each other. They don't have to be exactly the same, but they should be close. All right, and then the last thing we have at the bottom here are the parameter estimates. And so we have our intercept here. So y when x is 0 is equal to 41. But what we're most interested in is the slope of the predictor. And that's here in the row x1. And so our slope is 0.79659. This is the associated standard error. This is our t-value. And then our significance value, which again, it reflects exactly what the f-test is. So same p-value. The f and t, the f statistic and the t statistic will be different, but the p-values will be the same. So this is statistically significant, and so x1 is a significant predictor of y. And then here in the last column we have the standardized coefficient, which is 0.24. Okay, so looking at this, I'm going to go ahead and switch over to the an example write-up that shows how to interpret the results. And so for the simple linear regression, or this example with one predictor, it'll sound like this. A simple linear regression was conducted to test the linear relationship between y and x1. The results of the analysis suggest that y is significantly predicted by x1. And so we have a statistical sentence here. So we indicate what test we're using, which is the f-test. We indicate the regression degrees of freedom as well as the residual degrees of freedom. So on 1 and 148 degrees of freedom, the F statistic came out to 9.14, and that is less than 0.05. So P is less than 0.05. And where I get this information is in the ANOVA table. So on 1 and 148 degrees of freedom, the F statistic is 9.14, and P is less than 0.05. Okay. And then the next part is about the R squared. So approximately 6% of the variance in Y is explained by X1. And remember that the 6% is our R squared value. And then moving on to the coefficient, for every 1 unit increase in X1, Y is expected to increase by 0.80 units. And that's with rounding. And then again, we have a statistical sentence for our t-test. So our t on 148 degrees of freedom, which is always the degrees of freedom for the residual, so 148, is equal to 3.02, and p is less than 0.05. And then going back to our SAS output, that's from this row right here. So here's our slope. So for every 1 unit increase in x1, y is expected to increase 0.79659, which with rounding is 0.80. And then our t-value, and then our p-value. Okay. Let's go back to that write-up. All right, so that's the interpretation and the write-up for the raw coefficients. If we move to standardized coefficients, I've included the write-up here, and everything is exactly the same, except for now we're talking in terms of standard deviations instead of units, and the coefficient will change, but everything else stays the same. So everything highlighted here is what changes from the raw coefficients to the standardized coefficients. So the interpretation for the coefficient will be, for every standard deviation increase in x1, y is expected to increase by 0.24 standard deviations. And again, where we draw that from is this last column here. So 0.24 is the standardized coefficient. And so for every 1 standard deviation increase in x1, y is expected to increase 0.24 standard deviations. Okay. Going back to our syntax, we'll now move on to running our multiple regression with 2 predictors. So now we're going to predict y from x1 and x2. So again, we'll use proc reg. Our data set is the same data set, so reg data 2. And then the model is y is equal to x1. And then when you add a second predictor, it's just a space and then the variable name. So x1 space x2. Again, I'll put the slash in with stb to request these standardized coefficients. And then I'll go ahead and run that. Again, we get all of these extra plots that we're not going to worry about right now. What we're most interested in is the output for the regression analysis. So here's our ANOVA table. Again, we have the degrees of freedom for regression, the degrees of freedom for the residual, so 2 and 147, our sums of squares, our mean squares, our f value, and our p value. We have our r squared here, which is about 14%, our adjusted r squared, which is pretty close to the regular r squared, so there's no concerns there. And then we have a table for our parameter estimates again. So we have x1 here, the estimate, the standard error, the t-value, the p-value, and then the standardized coefficient. And then all of that same information here for our second predictor, x2. So looking at the interpretation and write-up for that, a multiple linear regression was conducted to test if x1 and x2 significantly predict y. The results of the analysis suggest that the regression model significantly predicts y. And then here we have our statistical sentence again. And remember that information is coming from here. So on 2 and 147 degrees of freedom, we have an f value of 11.84, which is less than 0.05. Okay. And then here we have our statement about the r squared. So the model accounts for approximately 14% of the variance in y. And then here we're moving on to the interpretations for the coefficients. So x1 significantly predicts y over and above the effect of x2. So our statistical sentence here for the coefficient, the t-test of the coefficient, and then holding x2 constant, y is expected to increase 0.72 units for every unit increase in x1. And so we get that information from this first row, or the x1 row of the parameter estimates table. So let's see. So our t-value on, remember the degrees of freedom for the t-test are the residual degrees of freedom, so 147. So on 147 degrees of freedom, our t-value came out to 2.82, and that is less than 0.05. So that's statistically significant. And so for every unit increase in x1, holding x2 constant, y is expected to increase 0.72 with rounding. 0.72 units. Okay. And then now for x2, in addition, x2 significantly predicts y over and above the effect of x1. So again, we have our statistical sentence here. T on 147 degrees of freedom is equal to 3.71, and it's less than 0.05. So holding x1 constant, y is expected to increase 0.89 units for every unit increase in x2. Going back to our SAS output, that's found here in the x2 row. So on 147 degrees of freedom, which is our residual degrees of freedom, our t statistic came out to 3.71, and that resulted in a p-value that was less than 0.05. So for every unit increase in x2, when we're holding x1 constant, y is expected to increase 0.89 units. All right. So again, down here, it's the same exact interpretation, but now we're using the standardized coefficients. So instead of in terms of units, we're talking in terms of standard deviations. And so if we go into our SAS output, the standardized coefficient for x1 is 0.22 with rounding, and then 0.28 with rounding for x2. So the only thing that changes are these sentences here. So holding x2 constant, y is expected to increase 0.22 standard deviations for every standard deviation increase in x1. And then similarly, holding x1 constant, y is expected to increase 0.29 standard deviations for every standard deviation increase in x2. All right. So we've gone over correlations. We've estimated a one predictor regression and went over the interpretation and write-up. And we also estimated our multiple linear regression with two predictors and went over the interpretation and write-up. So the last thing to talk about is if you want to compile this output instead of it just being in, so we have all of our output here that we've run today. And if you want to compile all of this stuff into a Word document instead of just having it in the results viewer for SAS, all you'd have to do is remove the asterisk before this line here, ODS RTF path. And remember, this is the file path. So for me, I want to put the file on my C drive in the datasets folder, and then I want to call it week4lab.rtf. And then down here, the last two lines, we also removed the asterisk. And then, so we have ODS RTF close. That will close the writing of the Word document, and then it will quit so that it can, it'll compile the Word document with all of the output. So if we highlight this and run it, it'll just take a second here for it to compile. And so here, in a Word document, we have all of the output that we saw in SAS. All right. And with that, that concludes today's video on correlations and simple and multiple linear regression in SAS.